Year 10 and welcome to some more chemistry. Today we are doing electrolysis of molten compounds. So do it now. I want you to do your daily challenge on Tassamai, and then I want you to write down what these words mean. Electrolyte, anode and cathode. So we're going to pause the video and do it now. Okay, Year 10, welcome back. So what do these words mean? Electrolytes are, of course, ions that are free to move in solution. They could be in solution or they could be in liquid form. So I'm just going to put liquid. Okay, and your anode, as I'm sure you'll remember, is your positive electrode. And your cathode is your negative electrode. Okay, so now we are remembering these words. Yes, well done. We're going to look at what happens when we do electrolysis of molten compounds. Okay, so what's going to happen when we make things molten? Yes, dear. Okay, so what happens is, for example, this is a molecule of, say, calcium iodide. We've got one calcium ion and we have got it ionically bonded to two iodine ions. All right, so we're going to heat it up. We're going to make it molten, and when it's molten, these ions stop being bonded together. They are free to move. So let's take our ionic bonds off and let's move it around, okay? They are now molten. They are free to move. So we're going to put in our electrodes, okay? So let's stick in a couple of... Oh, where's my electrodes gone? We're going to stick in a couple of electrodes like this, okay? And here we have our cathode, and our cathode is going to start losing electrons. And our nice positive calcium ion is going to like that. It's going to come up here and it's going to suck up those electrons that are going. But it wouldn't be a circuit if those electrons were lost. So our iodide ions here are going to come over here. And what they're going to do is they're going to give up their electrons. They're going to lose their electrons at the positive anode. Okay, so these electrons are going to go onto the anode and back into the circuit. And these iodines are going to bond together. And iodine is a solid, so it's going to go down. Both of these are going to go down and deposit at the bottom of our solution, and we can then take the solid products off. Okay, so we had calcium iodide, we made calcium and iodine. So we're going to write that in. Calcium iodide makes calcium and iodine. So this is our formula. CaI2 makes Ca and I2. Now the really good thing for this is we don't need to worry about balancing our equation. It is balanced. One calcium on each side, two iodines on each side. Happy days. Higher paper, okay? So higher paper, you need to do the half equations, the equations at each electrode. So we start off with the cathode, simply because the cathode is the one that puts the electrons in, so it's where we start our electrical circuit, as it were. So at the cathode, we have got calcium, and it's a 2+ ion. Now we can know that because it's in group 2 of the periodic table, so it's going to lose its 2 outer electrons. Okay, and we're going to add electrons to it to make calcium. Now just have a stop here and think, how many electrons do you think we are going to add? Let's think. Calcium has got 2 positives, it's got space for 2 electrons. Okay, so 2 positives and 1 negative gives no charge. No. 2 positives must need 2 negatives to make nothing. So 2 minus 2 is nothing, no charge. So that means we must need 2 electrons. Okay, 2 positives, 2 negatives make no overall charge. At the anode, what's happening? We're having iodide ions, which are I-, and we can tell that because they are in group 7, so they only need to gain 1 electron to move up to 8 electrons in its outer shell, and to make it all full and happy. So it's only 1-, and that's going to make iodine, and it puts electrons into the anode. Okay, it's lost its electrons. Instead of saying minus electrons here, because we're not losing them, are we? They're just moving off into the circuit. We're going to add the electrons on this side. Okay, we've got 1- on this side and 1- on this side. Happy days, it's balanced. Oh, but wait. You've got a little 2 there, haven't you? So on this side, we have got 2 iodine atoms, which means we're going to need to start with 2 iodides. So we've got 2 negatives here, which means we're going to need 2 negatives on that side to balance it out. Okay, the hardest part of the half equations is remembering that you need to balance the atoms as well as the charges. But once you know that it's going to try and catch you out with that little bit of sneaky, you're going to be fine. And now you know it's going to catch you out. Happy days. Okay, so I'm just going to mark on that this is higher paper only. Okay, so let's do another example. All right, so this is aluminium oxide. Okay, so what's going to happen here? Let's write it down. Aluminium oxide. Okay, we're going to heat it up, and all the ions are going to move apart. Remember, they're not actually bonded together with bonds like this. They're held together with that electrostatic force. Okay, so they're held together because the positives are attracted to the negatives. They're not sharing electrons, so the bonds are easier to break. You wouldn't know it from the amount of pulling I've got to do. So we have got all these aluminium and oxygen oxide ions moving around. Okay, and we're going to say cathode, negative electrode, our positive aluminium's going to go over there. It's going to pick up 3 ions and become aluminium metal and sink down to the bottom. Oxygen is going to move over to the anode, the positive electrode. It's going to lose the electrons, and the oxide is going to become oxygen. And oxygen, as I'm sure you remember, is diatomic. Okay, it looks like that. Now, before you say, hang on a minute, there's one left over. Oh, no, I've got to do balancing. Oh, Mrs. Smith, oh, that's just mean. Oh, I know, I've got a cunning plan. Why can't it make oxygen that looks like this? Ha ha ha. Why doesn't it do that? Well, the simple reason is because that's ozone. and if you're making that, it's going to stink and it's not going to be very good for you. And ozone naturally breaks up anyway into oxygen, and this would then go off and bond with another oxygen from a broken down ozone. So we're going to make oxygen and aluminium. So let's write that one down. Aluminium and oxygen. Okay, and we will write it down as Al2O3 makes Al plus O2. And we're going to set about balancing that. I'd like you to pause the video and balance it. Okay, do your best. And what I'm going to do is show you how I'm going to do it when you've done it. Okay, so what happens is you can see that we're going to need to do something because we've got an oxygen left over here. So what if we add another aluminium oxide, 2 aluminiums, 3 oxygens. Okay, so I'm going to add another aluminium oxide and see what happens. Right, well, this aluminium travels over to the cathode, stops becoming a cation, becomes solid aluminium. Now, what about our oxygens? This one can bond. There we go. You can do this with Lego, by the way. I'm not expecting people to have a Molly-Mod kit, and I'm fairly sure you won't be allowed to take that into a chemistry exam with you. So if you're doing this with circles or Lego, I don't mind. I'm doing this to show you that this is why we can't change the small numbers, okay? They've got to look like the same molecules, okay? So there we go. We now have aluminium. It didn't matter because these atoms, they don't really join to anything. It's a metallic bond. It's different. These ones, though, do need to be O2. So we added an extra aluminium oxide. So we had 2 aluminium oxides. And you can see we made 4 aluminiums. So I can put that number 4 there. And we made 1, 2, 3 molecules of oxygen. We can always check. 2 times 2 is 4, and we've got 4. 2 times 3 is 6, and over here 3 times 2 is 6. So we've got 4 aluminiums, 6 oxygens. 1, 2, 3, 4 aluminiums, 1, 2, 3, 4, 5, 6 oxygens. Yes, it has worked. It has balanced. Happy days. Okay, year 10. So for your standard paper, this is where I'm going to leave you now. So standard paper, you know everything. You can now do the worksheet. Don't do questions 5 and 6. It does say that on the worksheet because I've not taught you what you need to know for questions 5 and 6, but you can do questions 1 to 4. And the stuff I'm going to go through now is only in the higher paper. You are very welcome to keep watching because it is interesting. And you might just say, hey, you know what, let's watch this and just laugh because I don't have to know it. Haha, I don't have to learn this. It's great to know that I don't need to know that. So you might want to watch it just so you know the sort of thing that we're expecting the higher people to know, or you might want to stop now. So yeah, if you leave me now, it'll take away the very heart of me. Okay, yeah, sorry about that. My son just pulled a face and made me realise that maybe not. So yeah, if you leave me now, I will understand. And higher paper, let's continue. So there's something you need to know. We're going to look in the book again. Okay, so this is our happy mnemonic that you're going to have to learn about electrolysis, higher paper lovelies. And I know that I'm only expecting one of you to be watching this, but if this is used by anyone else, there might be some more people who need this. I'm not naming any names because it's going on the internet, but this is for one specific student. So, OILRIG and oxidation. You may know the word oxidation from Key Stage 3, where it meant adding oxygen. So if I have, for example, carbon and I oxidise it, yeah, that would just mean I added oxygen to it and I made, when we're ready, carbon dioxide. Okay, so I've oxidised my carbon to make carbon dioxide. And for organic chemistry, that's still correct. Oxidation is adding oxygen. But in organic chemistry, which is electrolysis, there's another definition. So don't think the old one was wrong. It's just it's not relevant here. So oxidation is loss of electrons. Okay, so if I were to oxidise a metal, say if I have copper, yeah, copper is a metal and I want to oxidise it. So it's going to make an ionic bond, which means it's going to give up its electrons. And look, I'm adding oxygen. So oxidation is still adding oxygen, but copper has given up its electrons and given them to oxygen to make it into an oxide. So oxidation is loss of electrons. That's nice and easy to understand. And so our oxidation equation happens at our anode. Okay, let's just write this here. Oxidation happens at the anode. We lose electrons. Okay, that part's nice and easy. The next one, reduction, is gain of electrons. Now, this always flummoxed me at GCSE. I couldn't get my head around it. Hang on a second. Reduction is gain. Reduction, you know what? Price reduced, the price has gone down, right? Reduction is gain. So we've gained something. It's gone up. How is that reduction? Okay, I'm going to tell you how. So at our cathode, we have got reduction. Okay, and this little dude here, when you do A-level chemistry, the charge on the ion refers to something called the oxidation number. What happens to the oxidation number when you add electrons? It goes down. You add electrons to something, the oxidation number goes down. Let's do a few examples, okay? So if I have vanadium 5+, I add an electron, I make vanadium 4+. That charge there, which refers to the oxidation number, it's not exactly the same as the oxidation number always, but in this case it is. Our oxidation number has gone down. Our oxidation number has been reduced. So that's why a gain of electrons is a reduction. And we can keep on going as long as we want. Vanadium 4+ plus an electron makes vanadium 3+. Okay, if I've got vanadium 4+ and add 2 electrons, I'm going to reduce the oxidation number by 2. So our charge is going to reduce and we're going to make vanadium 2+. And it's exactly the same for the negative ones. Okay, so if I have iodine plus electrons, I'm going to make 2I-. Our oxidation number here is 0. Our oxidation number here is -1. It's gone down still. Okay, so reduction is gain of electrons because the oxidation number's gone down. That bit you do not have to worry about. Okay, that bit, I'll cross it through, that bit's A-level chemistry. So you don't have to worry too much about doing the numbers. Those are half equations though. That one's definitely A-level chemistry. So you should be able to say, oh yes, that's a half equation, I can see what's happening, but that's why reduction is gain, because that number there is going down. yeah, that's all you need to know. OILRIG, oxidation is loss of electrons and happens at the anode. Reduction is gain of electrons and happens at the cathode. If you can remember that without remembering why, that's fine. But I do know that I really struggled with that at GCSE because no one put reduction into terms of this charge number going down. And that's all you need to know. You can now go and try and do questions 1 to 4 and question 7 on the worksheets. Good luck with it. Stay safe. And yeah, see you for another exciting science video very soon. Bye.